Good afternoon, students. Good afternoon, all present over here. So today in our presentation, we're going to discuss about subject of operating systems. In that, this session is entirely going to discuss about the disk scheduling. So myself, Vijaybabu, Assistant Professor, Erode CSE Department, Computer Science and Engineering Department, Erode Sengunthar Engineering College, Erode Sengunthar Engineering College. Okay. So disk scheduling. So normally, before I'm going to start this session, so I'm going to give some brief introduction about what is file management, how to accessing the disk, all those things. So initially, you know very well about operating systems, various resources. So one of the resource is file. So in this file, how the contents are is going to be stored, and how it is going to be providing permissions to the user to accessing the particular informations or particular files. So one of the part of this file management, and at the same time the memory allocation, the memory is also one of the resource of OS. In that memory allocation, one of the part of this memory allocation is scheduling, disk scheduling. Before that one, we are going to accessing the disk, how the disk is going to be utilized in the various kind of dimensions, and how it is going to schedule the process, and it is going to give the access permissions. All these things is going to discuss in this particular disk scheduling, where simply we are scheduling the process and how it is going to be done by in the means of magnetic disk or like secondary storage devices like that, magnetic disk, magnetic tape, like that. So here we especially specifically we're going to discuss about how the process is to be scheduled in a disk. This is what we're going to discuss in this particular topic. Okay, from that one, we're going to start from these layers of IO system and the main functions. What are all the main functions it is going to be performed in the IO? So IO, memory, file, all are the resources of OS. Okay. So in that one, the bottom layer, you look at that, this is a hardware. In this hardware, it is used to perform the IO operation. So that whatever this IO operation means, input output operations. Input means what all the informations we're going to feed into the system. It is going to be an input operation. Output operation, what are the thing we just going to get it from the particular system is nothing but the output operation. So all these things is going to be performed through this particular hardware. Okay. Next layer is interrupt handlers. So here this interrupt handlers is going to give the hint, and it's going to indicate to wake up the device drivers whenever the IO process is going to be completed. Okay. Next layer is device drivers. This device drivers, it is used to set up it in the system, and it's going to check the status whether the devices are ready to perform the operation. That is what the device drivers role is going to be defined. Then device independent software. In this device independent software, it is used for the instances such as naming the process, protection, blocking, buffering, and allocation. Here this is one of the important layer, because here only they are naming the process, and they are going to give some kind of protection mechanisms, and how the unauthorized thing is going to be blocked, how the buffering is to be done, and how the resource is going to be allocated. All these things is going to be done in this particular layer. Next, user processes. This user process is used to make IO card, formatted IO, and then spoofing. All these things is going to be done in this particular layer, the user process layer. Okay, these are all the various layers, namely hardware, interrupt handlers, device drivers, device independent software, then user processes. Okay, all these things it is going to be specified in this user space IO software. Okay, next, disk structure. So kindly notice all these things. Don't don't forget to note it down. Okay, the disk structures, disk drives are addressed as one dimensional arrays of logical blocks, where the logical block is the smallest unit of transfer. So in this disk structure, all thing is going to be defined in terms of blocks. Blocks are nothing but the small unit of transfer. Blocks are nothing but a defined small unit of transfer. Next, the one-dimensional array of the logical blocks. The one-dimensional array of logical blocks is mapped into the sectors of disk sequentially. So here one of the things is you have to be noted down, that is one-dimensional array of logical blocks. What are all the one-dimensional array of the blocks are going to be a one-dimensional array, and it is mapped to the sectors of the disk. So yeah, in this disk structure is going to be a block, logical blocks. It is going to be a small unit of transfer. So in the this blocks, it's a one-dimensional array. It is going to map of the sectors of the disk. The disk in the disk is going to be is going to include the various sectors. It is going to be splitted as sectors. So the blocks are going to be mapped with the sectors. So through this mapping, the blocks is used to providing the information to the sectors. Okay. For example, we can say sector 0 is the first sector of the first track. Okay, like that. It is going to be the mapping is going to be done in this manner. Okay. At the same time, the mapping proceeds in order through the track, then the rest of the tracks in that cylinder, and then through the rest of the cylinders from outermost to innermost. So what I am trying to say is, each and every block is going to be mapped with the sectors of disk. Okay, for example, if we say sector 0 is going to map with block 1, sector 1 is blocked with block 2, like that it is going to be carried the process, and it is going to cover the outermost to the innermost of the cylinder. Cylinder means here you name it as disk. The disk is going to be in a round shape, in cylinder shape, so that only they name it as cylinders. So in this manner only the outermost is going and to innermost coverage is going to be done in the disk. Okay, so before that you should know about what is track, what is sector, and what is cylinder. All these things you should know. You already have some idea about all these things. Okay, tracks, what is meant by track, what is meant by sector, what is meant by cylinder, all these things you should know very well. Okay, then only you can able to proceed in this particular topic. Okay, next, disk scheduling. So now we are going to get into the topic disk scheduling. Okay, so why we are going for disk scheduling, for our purpose? It is very very important, you should know very well. So the operating system is responsible for efficient use of hardware. Okay, that is what the main responsibility of an OS. An OS, that's only we are naming it as OS as a resource manager, process as a resource, memory as a resource, IO as a resource, file manager as a resource. So the OS role is very crucial. So this OS is only responsible for the effective usage of the hardware, efficient usage of the hardware, especially for the secondary storage devices. Okay, so what is the thing is actually we are going to discuss here. So just how many time it took, in how much quickly it is used to accessing the particular disk, and as well as the bandwidth rate. All these things is going to be done through this particular disk scheduling. Okay, so the disk scheduling is it especially for accessing for quick accessing time, and as well as disk bandwidth. For that purpose only that we are doing the disk scheduling. Okay, here the access time has two major components. Access time has two major components. One is seek time, another one is rotational latency. Bead.
ஒரு செகண்ட் இருக்கும் தெரியும்
Okay, the access time has two major components. One is seek time, another one is rotational latency. Okay, seek time is nothing but what is the time is required, okay, for the disk to move the header from to move the header to the specific sector. For example, if the head of the head of the disk is in one particular position, okay, either it is starting position or middle position, like that. So what is the time is required to reach the destination of destinated sector? அந்த டெஸ்டினேட்டட் செக்டார் ரீச் ஆகிறதுக்கு தேவையான டைம், அந்த டைம் தான் the name of the time is seek time. So seek time is the time for the disk to move the head from the cylinder to the specific sector, desired sector. That is what seek time. Rotational latency or rotational delay. So that is what is that particular thing is. It is the additional time waiting for the disk to rotate the desired sector to the disk head. So rotational delay is nothing but it is additional time. Additional waiting time is required for the disk to rotate the desired sector to the desired disk head. Okay, that is what rotational latency. So additional waiting time for the disk to rotate the desired sector to the disk head. Okay, normal time, the additional time, according with the normal time, the additional time is needed to rotate the disk to the desired sector to the disk head. That is what rotational latency. So the main purpose of disk scheduling is nothing but to minimize the seek time. At the same time, distance. All these things is going to be considered in this disk scheduling. At the same time, disk bandwidth. What is disk bandwidth? Disk bandwidth is the total number of bytes transferred divided by the total time between the first request for service and the completion of the last transfer. So bandwidth, you should know what is meant by bandwidth. So disk bandwidth is nothing but is the total number of bytes transferred. Total number of bytes transferred. This going total number of bytes transferred divided by the total time between the first request for the service and the last transfer. Okay, that is what the formula. Total bandwidth in the disk bandwidth is nothing but total number of bytes transferred by divided by total time. So this total time is nothing but first request for service and the last transfer, the completion of the last transfer. That is what total time. So number of bytes transfer divided by total time. In that, the first request for the service and the completion of the last transfer. That is a formula. By applying this formula, we can get disk bandwidth. Okay. So what is seek time? What is rotational latency? What is disk bandwidth? You should know very well. Okay. Disk scheduling. In this disk scheduling, several algorithms are existing to schedule the servicing of disk IO request. Okay. Several algorithms are existing to schedule the servicing of disk for corresponding IO request. Several algorithms are available to schedule the servicing of disk IO request. Okay, some of the example is there: 98, 183, 37, 132, 14, 124, 65, 67. These are all the head movements. Okay, now head pointer is at 53. This is example they are given. We are just taking as an example to explain the disk scheduling. Okay. So first one is FCFS. So first one is FCFS, first come, first serve. Okay. See, first come first. Whatever the request is coming first, that request is going to be served first. That's what they name it as first come first serve. So now the head starts at 53 because in this example I give it as head pointer in 53. It starts with 53. Okay. So from 53 where it has to go in queue. Already the queue is also given. Note it down. 98, 183, 37, 122, 14, 124, 65, 67. Okay. Head pointer starts with 53. Okay. From 53 in the queue first thing is 98. So from 53 the head moves to 98. After that what it is coming as a request is 183. So from 98 it goes to 183. Okay. From one now what is the next one is 37. From 183 to 37. What is the next one in the queue? From 37 to 122. Okay, from 132 to next one in the queue is 14. From 14 to 124. That is the next queue. Next in the queue. After that, this goes to 65. After that, it goes to 67. So now you calculate the head movement, total head movement. It will give you 640 cylinders. Okay, the 45, then 85, 130, then 30, then 146, 276, then 276 to 87. 87 means 364, then 364 to 110, 110, 474, 474 to 120, 594, 594 to 594 to 59, 643, 640 cylinders is going to come. Total number of head movements. Just you're going to calculate the difference from the starting and the time taken for the last answer. Completion of the last answer. That is what the formula. You can apply it and you can find out the total head movements. Okay. Okay, that's what first come first. So whatever the request comes first, and it is going to be served first. That is what FCFS. Total head movement for the given problem for FCF using FCFS is 640 cylinders. 640 cylinders. Okay. Note it down this diagram soon, and then you can work it out on your own. First, look at this, and then you can work it on your own. Work it out on your own. Then only can aim to know about what is FCFS and how it is going to be working. Okay. Make it fast. Make it fast, ma. Make it fast. இல்ல இல்ல note it down. Okay, ma. So FCFS, whatever the request comes first, it is going to be served first. Okay, next one, SSTF. This is one the expansion for SST, shortest seek time first. Shortest seek time first. From this expansion itself, we can identify the process, how the process takes place. Okay, it selects the request with the minimum seek time. Okay, it selects a it selects a request with the minimum seek time from the current head position. So, for example, if the head starts at 53, okay, so this one is going to select which request time is minimum, seek time is minimum. Is going to select the particular thing. After that, which is the next minimum. After that, which is the next minimum. Like that, it is goes on, and it is going to visit all the heads, what all the requests which is presented in the queue. Okay, it is what it is similar for the CPU scheduling, SJF, shortest job first. How the shortest job first it is going to be worked. In the same manner, SSTF scheduling is also going to be performing the process, executing the process. Okay, so SSTF, the shortest seek time first. Whatever the minimum seek time is there in the queue, that is going to be selected from the current head position. After that one, it is going to select the next minimum, and then it goes on and it is going to complete all the requests in the queue. Okay, for example, you see here from 53. So in the problem itself, they given as the starting head position is 53. Okay, from 53, which one is minimum seek time? If we take 37, it travels backwards up to 16. If we take 65, it is used to take only 12. So it's going to choose 65. After that, 65, from 65, 67 is nearer. Right to that. Right. From here, 67, which one is the minimum? This is the difference between 98 and 67 is 31. 67 to 37 is 30. So it travels through 37. After that, 37 to 14, 14 to 0. Okay. Then from 0 to 98, 98 to 122, 124, 183. The simple thing is from starting from the head position, which one is minimum seek time from the current head position? Compared with the 37, 65 is nearer, so it's going to choose 65. From 65, then it goes to 67. Then it's going to search which one is minimum seek time. From 67 to 98, it requires 31. From 67 to 37, it requires 30. So it chooses 37, then 14, then 0. After that, from 0, it travels all the remaining requests. So no other go. From 98 is nearer compared to 122. So then 122, then 124, then 183, then 189. So the thing is, from the head position, it's going to select the minimum seek time, and then it is going to uh, reach the particular request which is presented in the queue. Okay, this is what SSTF. So compared with the FCFS, in FCFS, whatever the request comes first, it is going to be served first. That is what FCFS, first to come, first to serve. Then SSTF is nothing but shortest seek time first. Whatever the from the head position, which seek time is going to be minimum, that one is going to be selected, and it is going to be traversed throughout the particular queue request. Okay, from that one, then in this manner only it is going to be processed and it is going to be done. The cylinders, it is, if you go and calculate the total number of the head movements, is nothing but 236 is going to come. We just to calculate the difference, what how we did in the first thing, first type. Like that, in the same manner, if we find out the total head movements, it is going to give 236 cylinders. Okay, that is what the difference between FCFS and SE. In FCFS, whatever the request comes first, it is going to be served first. In SSTF, from the head position, which seek time is going to be minimum, that is going to be selected, and it is going to be processed, and it is going to be executed. Okay. Then scan. The disk arm starts at one end of the disk and moves towards the other end, servicing request until it gets to the other end of the disk. But the head movement is reversed and servicing continues. So scan means like that. If it starts at the one end, it completes the one end completely, then it moves to the next end and it is going to be service all the requests, and then it is going to be reversed back to servicing the all the other heads in the queue. So this is what scan. Simply we can say how your, if you are going for scan in the lab and all, laboratory and all, how the scan is going to be performed. In that manner only the disk scanning is going to be done. The disk arm starts at one end. It starts from the one end. It completes the entire thing in the first one end. Then it starts moving towards the other end, and it is going to servicing all the heads. Then it is reverse. The movement is reversed, and servicing continues like that. Like that, it is going to perform. Sometimes we can name this particular thing as elevator algorithm. Elevator algorithm. Okay. See, scan 53. So in SSTF, it chooses the minimum seek time and it proceed further. But in the scan, it starts from one end, completes everything in one end, then it moves to the next end. Okay, from that, while it is moving from the one end to another end, at that time it is used to service all the requests, and then once again it is going to be reversed and its servicing continues. See, from 53, here only the 3 entries are there from that, but this side it is going to have 7 entries. So it starts from the left side and it completes it. Then it is goes to 53, 65, 67, 98, 122, 124, 183, 189. Okay, that is what the scan is going to be performed. Okay, so 189 is not given in the problem, so it stops 183 itself. Okay, so if you calculate the total head movements, it's going to give 208 cylinders. Okay, 208 cylinders. See here, total head movement of 208 cylinders. Okay, so kindly note it down. The first of all, you should note it down this diagram. I just forgot to tell about that. Note it down. Kindly note it down this SSTF first. Then you note it down. Scan. Okay. Then make it fast, ma. Note it down fast, ma. Make it fast. Note it down fast, ma. After that one, just note it down the scan also. Scan, how the scan scheduling process is going to be done. Daily note it down. இப்போ இங்கே வந்து இதை போட்டேன். இங்கே இதை வந்து இங்கே ஆயிட்டு ஒன்றும் பிரச்சனை இல்லை, ஆயிடுங்களா? Okay, just note it down fast, ma. Scan. Right. Next one. C scan. C scan. This C scan. This we can name it as you have some idea about circular queue. In that manner, only the C scan is going to be performed. The process. Okay. So it provides uniform wait time than scan. Okay, what happens means in scan it starts from one end, it completes everything in the one end, and then it is go to move to the next end. At the time it's used to servicing the request in the other end, then it's reverse back and the servicing continues. That is what we discussed in scan. In C scan, as it is what the scan is going to doing, the same manner only the C scan is also is going to done the servicing the request. Okay, when it reaches the other end, what happens, it immediately goes to the starting point of the other end, beginning of the end disk, beginning of the disk, without servicing any request in the middle on the return trip. So the head movements emptily travels from one end to another end without servicing the request. Once it reaches the one end of the disk, then immediately it starts and move to the beginning of the disk, then only it starts and servicing the request. So while it is returning trip, at the time of the returning trip it never servicing any request. That is what the difference between scan and scan. Thoroughly you should understood clearly, thoroughly you should understood. It is very very important, my dear students. So in scan it starts from one end, completes one end of the disk, then the head movement is starts and moving to the another end. At the time of moving to the another end, it is going to servicing the request. Once it is completed, then it is going to be reversed and servicing is going to be continued. This is scan. In C scan, one, as it is what the scan is doing, the same manner, similar manner, C scan is also is going to processing the request. Then it once it reaches the one end of the particular end of the disk, immediately it is returning back to the beginning of the disk. At the time of returning time, it won't service any request. Okay, that is what difference between scan and C scan. Okay, so you see this diagram, you should clearly know very well. 53 from starting, then it travels throughout the end, one end up to the end of the one disk, then it starts from that particular end to the beginning of the disk, then only it is used to service. So once it is travel returning trip, it won't service any request here. See, this is going in this direction only, but it won't servicing the request of 3714 like that. Directly it goes to the another end of 0, the other end is 0 starting beginning of the disk, then only it is start servicing the remaining request. It is a C scan. Okay, so in scan it's not like that. It starts and it completes one end. After that, the head is moved to the another end, then it's servicing the request. Once it is going to be returned reversed, and then the service goes on. Okay, but the C scan, it starts and moving and servicing the request as it is what it goes in scan. Once it reaches one end, then immediately it reaches to the beginning of the disk, then it starts servicing. But the only thing is, at the time of returning trip, it won't service any request. Okay, that is what the difference between scan and C scan. Okay, so just kindly note it down this diagram also, my dear students, please make it fast, ma. Make it fast. The next one, see look. See look. It is also another version of C scan. So here, just note it on this point. It is very important. Arm only goes as far as the last request in each direction, then reverses direction immediately without first going all the way to the end of the disk. Okay, so the arm is going to be traverse as the last request in each end, each direction. Then it is going to reverses the direction immediately without first, without first going all the way on the end of the disk. So in the C scan, if he covers one end, then it is goes to the beginning of the disk like that in C scan. But in C look, it not going to the different like that. If it reaches the another end, then it is going to be reverses direction immediately. The returning trip it is used to servicing the request. That is what the difference between C scan and C look. In C look, once it on the returning trip is used to servicing the request, but in the C scan it won't service any request in the returning trip. Only after reaching the beginning of the disk, then it only servicing starts. But in the C look, once it reaches the end of the disk, immediately it reverses the direction immediately. Then it starts servicing. Okay. That is the difference between C look and C scan. Just look at the diagram. You should know clearly. So it serviced all the requests in one end. Then what happens means when from 183 directly so one thing you should be sure that is what happens means in C scan it reaches the end of the disk, one end of the disk. Immediately it's returning back to the beginning of the disk in C scan. But in C look, it reaches it won't reaches the last request in each direction. Before that request, it ends its movement, then immediately reverses back to the reverse direction. But what is the meaning is once it is returning, it not going to reach the beginning of the disk. Next to the beginning of the disk, what it is there 14. Then it requests the 37. That is the difference between C scan and C look. In C scan, after reaching one end of the disk, immediately returning back to the beginning of the disk. But in the C look, it never deals with the last service of in each direction. Before that last service, it stops its request, then immediately reverse to the direction. And also in the reverse direction, it won't go to the beginning of the disk. After that beginning of the disk, what is the service is there? It is going to service a particular request, then it is goes on in that particular remaining request is going to be processed. In that manner, only the C look is going to be perform the process. Okay. So note it down, pa. Note it down clearly. Note it down, ma. Note it down. Note it down clearly, ma. Note it down, pa. Can I note it down fast? So after that, selecting a disk scheduling algorithm. So how we going to choose select a disk scheduling algorithm? Which algorithm you going to choose? So according to the request, what it is given in the particular thing, we going to choose the algorithm. Minimum number of head movements. Which algorithm is going to give? You have to choose a particular algorithm. So how are we going to choose? So if you compare with 5 different thing what we go through now, FCFS, SSTF, scan, C scan, C look. So you compare the scan and C scan, mostly it is used to perform better because it completes one end completely, then only it is used to move to the next one, like that it is used to perform. So scan and C scan perform better for systems. Okay, whenever there is a heavy load on the disk, you should have to go for scan and C scan. Okay, so at the same time, the performance of the particular system, particular disk, depends on the number of requests, number and types of request. How, what type of request is going to be posted on the particular disk? Based on that only the performance of the disk is going to be assessed. Okay. At the same time, you should know very well the request for disk service. The request for disk service, how the disk service is going to be request is going to be influenced by means of influenced by file allocation method. What kind of allocation method we going to implement in the disk? That is based on that only the request is going to be carried out. Okay. The disk scheduling algorithm should be written as a separate module of the operating system, separate module of the operating system, allowing it to be replaced with a different algorithm, to be replaced with a different algorithm. Whenever it is necessary, it is used to be replaced with a separate algorithm, different algorithm. Okay, so based on the performance that is going to depends upon the number and the types of different requests. Okay, based on that only the thing is going to be done. At the same time, the request of the disk service, it is going to be influenced by the file allocation method. What kind of file allocation method we going to impose on the disk? Based on that only the request is going to be done. Okay. Next, RAID. RAID is nothing but redundant array of independent disk. Redundant array of independent disk. There are several levels are there in RAID. Okay, so before that, going to the RAID, you should know how the disk drive is going to allocate the space to the various processes, and how the this scheduling is going to be done, what kind of algorithm we're going to choose, how the performance is going to be assessed, and how the request is going to be carried out in the disk. All these things you should be thorough, then only you can able to understand what is RAID and all those things. Okay, so you should be very clear about what is mean by disk allocation, what is mean by file allocation, what is mean by IO request, what is mean by performance, what is mean by scheduling, what is mean by disk scheduling, how the request is going to be carried out in the disk scheduling. All these things you should be very clear, then only you should know, you should able to understand the RAID concepts and all those things. So before that, we should go through all these things what we did in this particular session. That is, start with what is disk scheduling. We start with user space IO software, various layers. What all the various layers are there? Hardware, interrupt handlers, device drivers, device independent software, user processors are the different layers in the IO system. Then we discuss about disk structure. In disk structure, how the disk structure is going to be defined. Array of is going to be defined, the array of logical blocks. Each and every block is going to be mapped into the specific sectors. Okay, the sector 0 is mapped with first block 1, like that it is going, mapping is to be done. Okay, so you should understand the track, what is meant by track, what is meant by sector, what is meant by cylinder, all these things you must know. Then we discuss about what is meant by seek time, what is meant by rotational latency, disk bandwidth, all these things. Then we started what is meant by disk scheduling, and we take one example. With that example, I am explained the various disk scheduling algorithms. What is meant by FCFS, first come first serve. Whatever the request comes first, it is going to be served first. It is FCFS. Next is SSTF, shortest seek time first. From the head position, which seek time is going to be a minimum one, that particular request is going to be chosen, and then it is going to be processed in the same manner throughout the particular queue request. Then we discuss about scan. The discom starts at one end of the disk. Then it is going to move towards the other end, and it is going to service all the requests in the returning tray at the other end of the disk. Okay. That movement is reverse and servicing the request. Sometimes another name of the scan is something about elevator algorithm. Okay. Then we discuss about C scan. The head moves from one end of the disk to the other. If it reaches one end of the disk, then immediately it travels to the beginning of the disk. Then it start uh, servicing the request. At the time of returning trip, it won't service any request. Okay, that is what C scan. Then we discuss about C look. In C look is a version of C scan. It deals with the last position of the in each direction. Before that last position, it stops immediately. It reverses back to the last before request in the other direction, and then it is going to servicing the request. These are C look. Okay. Then we discuss about how to select the disk scheduling algorithm. So what is how the performance depends, and then how the request is going to be carried out. All these things we're going to discuss. Most number of scenarios, the suitable algorithm is nothing but scan or C-scan is going to be suitable one for various kind of reasons. One of the reason is heavy load on the disk is there, means you can go for scan and C-scan. Okay, that is very very important, my dear students. Okay, so these are all the things we discussed now. So you should go through all these things. So what is IO, how the IO request is going to be done, then what are all the various processes are uh, indulged in the particular thing, what is mean by what is mean by uh, disk scheduling, how the disk scheduling is to be carried out, and then what are all the various algorithms are there. All these things you should be thoroughly know. You should uh, manipulate all these scheduling algorithms with the different kind of request. Then only you should know the difference between each and every algorithm. Each and every algorithm having its own unique procedure. Each and every procedure having its own unique type of executing the process. That should be very clear. What is FCFS, what is SSTF, what is scan, what is C-scan, what is C-look. All these things are very, very important. So if you gone through in depth about all these things only, then only you can able to understand the difference between all these algorithms. Then you should analyze after completing the tracing part. You should calculate the total number of head movements. After that, only find out the head movements. Only you should uh, discriminate which one is going to be a effective one for this particular given request. For this given request, which algorithm is going to be efficient one and adaptable one to proceed further. So that is what this kind of topic is elevating to you. Okay, while if you find out any doubts, find out any issues, immediately refer me. I am ready to help you at any time. Okay, so kindly go through all these algorithms, all these concepts what we discussed in this session. Then you work it out with a different example. So I take it the same common example for all the algorithms. You can try with another kind of sequence of requests, and also head movement starts at where. So just change all the values, then you work it out that all these algorithms, then only came to know about which algorithm is efficient in all the times. Okay, for what purpose, for what particular reason this one is going to be a effective one, you should know very well. Okay, so you should try it on your own with a different example, then you can come back, then we will discuss about what is raid and all those things. Without practice, you can't able to understand the raid concepts and all. Okay, so this is very important.